final round, we want you to design the card game War using object-oriented programming. All right, before I dive in, I want to clarify the scope. Should this handle just a single round of War or the full game until one player wins? Let's go for a full game. 2 players, 52 card deck until one player wins all the cards. Keep it classic. If there's a tie, we go to War. Each player draws 3 cards face down and then 1 face up. The winner takes the whole pile. Now, in terms of functionality, we probably need to model 3 main entities. We need to model a card class with a rank, but we technically actually don't even need to model the suit. It doesn't matter in this game. We need a deck class that can shuffle and deal cards, and then we need a player class that can hold a collection of cards. Naively, I'd keep each player's cards in a list. In each round, I'd pop the top card, compare values, and append them to the bottom of whichever player wins. If there's a tie, I'd recursively call the function that holds cards until the tie breaks. Interesting. What's the downside to that approach? Yeah, appending to a list and popping from the front of a list in Python is O of n time each. Over many rounds, it could get inefficient, especially if we simulate hundreds or thousands of rounds. Exactly, how could you make that more efficient? I could switch to using a deck, a double-ended cube. This allows for O of 1 pop and append on either side of our deck. So both players' deck can be modeled as cues to simulate the flow of cards. Nice, that also reads naturally. The players are drawing from the top and placing 1 card at the bottom. Exactly, I'd also create a war game class that encapsulates the entire game. It'll handle initializing the deck and distributing cards evenly, looping through rounds until one player runs out, and managing wars recursively or with a helper function. Good, but what about handling ties that go too deep? Say one player runs out of cards. Good point. I check before each war if each player has enough cards. If they don't, the other player automatically wins. I can handle that edge case pretty cleanly. Nice catch. How about extensibility? Say we wanted to add logging or multiplayer or some sort of high score. I would design the war game class so the round logic is separate from the card handling logic. That way we can add methods for observers or analytics. Also, since we're using classes, new game types like poker or blackjack would be easy. You just have a game-based class that it extends. Perfect. What's the data structure takeaway here? The key here is using a deck for efficient O of 1 operations for our cards. The naive list version works, but it's not scalable or efficient. Awesome, you got the job. I'm making a video like this each and every day to help you improve your pattern recognition for software engineering interviews. If you found this video helpful, drop me a follow. I'll see you tomorrow.